Hi, everyone, and welcome to our session on AWS RoboMaker. You probably saw us up here frantically working with the slides. We had a beautiful slide that we're going to show you on NASA InSight lander. We wanted to celebrate the success. NASA JPL, yes, for a step forward for science. It's actually mind-numbing to realize that it hit the atmosphere 12,000 miles per hour. It had to hit it exactly at a 12-degree angle or bounce off into the atmosphere, go crashing, and they did it. And so it's humbling. That's real rocket science. It makes what we do look easy. But we've enjoyed a long partnership with between AWS and NASA JPL on we've started a number of services together, including this one that you're going to hear about today, and you'll hear more about that later in the presentation. So with that, I'm Roger Barget. I'm the general manager. I'm here with my colleague, Ray Zhu. We have customers from Stanley, Black & Decker and NASA JPL up here with us today. And so we're going to just dive in. So robots are being used for some incredibly useful tasks. Things that humans couldn't do, wouldn't want to do, delivering packages through the air, lifting up racks that contain thousands of pounds of merchandise so that we can get your package to you within hours. And roboticists are actually solving some incredibly challenging problems. In the upper left hand, you see a robot being developed at the University of Washington that has cameras that will recognize the food that the individual is eating. And the individual can use their voice to tell them exactly what they'd like to eat. And the robot will pick up the right utensil, get the food, and approach the person in a way that they're able to eat and live independently. Lower left-hand corner is Leah, an intelligent robotic walker, which is, again, powered by RoboMaker that allows voice interaction through Amazon Polly and Amazon Lex. On the right-hand side, you see the NASA JPL Rover, which is open source for roboticists to start to work with. So these individuals have incredibly hard problems to solve, but there's another class of problem they have to solve, which we think is frankly unnecessary. Just to get the team up and running, you have to have a consistent robotics environment with the right DLLs, all the same tools. It can take hours or days for an individual to get it done, let alone setting it up for the entire team and ensuring consistency. And as you heard earlier in our talk at Midnight Madness, robots are things that sense, compute, and then take action. And in many cases, as a developer building a robot, you have to tackle the whole 9 yards. You have to actually write software for the sensors. You have to write drivers for the actuators, and then write your own logic. You have to go soup to nuts. And if you want to make it intelligent, you have to write some special code for machine learning. Pretty soon, your team's getting large, and your project is missing its deadlines. And to the most part, it's a closed platform. You have to write the software from scratch. And limited resources. I can't tell you how many startups that I have talked to that said, we understand the value of simulation from when we were learning robots, the ability to be able to test the software, test the sensor, long before the robot's actually built, but we can't afford time to go set up a simulator. We can't afford the hardware, the people to maintain it, and even large teams, large companies that have large robotics efforts actually find that managing simulation becomes burdensome because it can take lots of people, lots of hardware, and when you're not simulating, it's just sitting there collecting dust and costing you capital expenses. So the reality is, tackling all these problems, which adds no value to the robot itself, leaves very little time for innovation. This is the problem that we have set out to solve with AWS RoboMaker. If you're in research or an academic and have been in robotics, you realize that we've heard this story before. Academic research was being slowed up. A group at Stanford said, hey, what if we started open sourcing all the software we wrote for robots so others could build on top of us? Willow Garage was started, and for the past 10 years, Willow Garage and Open Robotics have been maintaining something called the Robot Operating System, and it's not an operating system. It is a piece of software, a message bus that will allow sensors to sense, put a message on a wire with a topic, and if an actuator wants to respond to it or a control program wants to reason about it, it listens for that topic, it processes it, so it's a many-to-many pub-sub framework. Multi-platform, multi-language, so choose your language and you can code to it. Open source, BSD, Apache, extremely popular in academia. And when you talk to commercial robotics, you actually find it's widely used in commercial robotics. Again, a platform made for research has been widely adopted for use in research. And you might ask, well, what would you get with it? Well, because it has been used in so many places, sensors such as LiDAR, FLIR, depth camera, even the Kinect sensor works correctly on ROS. algorithms. There's a nav package, there's SLAM packages. There's a whole ecosystem of reasoning software out there for navigating or moving a robot. In addition, simulation, both 2D and 3D simulation. That lower left-hand image right there I thought was beautiful. It was presented at ROSCONF earlier this year, where NASA was simulating the moon and the light they have because of the atmosphere. And so they're tuning Gazebo Simulator to actually do realistic simulations of the moon. There's another presentation there this year about using ROS for actually building a robot that's going to fly on the International Space Station, and it's going up in a few months. Debugging. You can turn debugging on your robot. You can see the ROS messages, make sure a message is not being lost. You can do tracing. It's very rich. Those are actually screenshots from our service. You have logging and testing as well. You can see the ROS log messages. So again, this is an incredibly rich ecosystem to tap into for software that you can reuse. It's open source. And where's it being used? You see it being used in drones in the air for ROS. You see it being used underwater. Self-driving vehicles, industrial arms. In fact, industrial ROS conference is happening in a couple of weeks where industries are going to be talking about how they're using ROS in industrial settings. For home robots, for education, the Turtlebot is running ROS. And again, on the International Space Station, there already is a robot in the International Space Station right now running on ROS. So the bottom line is, anywhere you want to go into robotics, you're going to find associated ROS software on which you can build. So is it perfect? No. It was built for research. And we talked to companies and said, what did you have to do to actually use it for industrial robotics? Well, they said it has no security. The performance needs to be tuned up. It has to be more performant, more secure, hardened in various ways. So there's been an initiative that the industry community has picked up. We're one of the founding members for something called ROS2. And you can just simply think of it as a commercial-grade version of ROS, Linux for robotics, where a number of companies are contributing to it. And what stays the same? It still is Node, messages, publishers, subscribers, command line and graphical tools, so most of the ecosystem is fully intact. But what's new is a middleware interface based on DDS. It's a layered architecture, data security, no single point of failure. It's a much more robust runtime on which to be running ROS. And again, the technical steering committee includes companies like Intel, Bosch, Toyota Research, Open Robotics, LG, and Amazon. And we're all contributing source code, adding security, adding performance to it. So in a nutshell, what is our strategy? What is the business strategy? Before I turn it over, and we'll take you down at a deeper level. We're building on ROS, that's out there today, and ROS2 as a substrate. We're putting on top of that a cloud robotics development environment. We're layering on our AWS services. You'll hear more about that. We're offering simulation as a service, so if you just want to simulate an individual part, or if you want to simulate hundreds or thousands of robots, you'll hear more about that in Ray's presentation. This is going to lead to productive robotics developers with AWS RoboMaker. With that, I'm going to turn it over to Ray to take you on the rest of the tour.
Well, thank you, Roger, and good afternoon, everyone. Super excited to be here today to tell you a bit more about AWS RoboMaker. AWS RoboMaker provides 4 independent yet integrated capabilities. A development environment in the cloud for you to start writing your robotics applications without any setup or configuration effort. Cloud extensions for ROS to bring the power and intelligence of the cloud into your robots. A simulation as a service to let you run large-scale and parallel simulations with zero infrastructure provisioning or management. And a fleet management service for you to do over-the-air application deployments and updates while the robots are in use. Now let's dive into these 4 capabilities one by one. First, a dev environment in the cloud. If you are a developer or a robotics developer, oftentimes you will find that before you can start writing a single line of your application code, you need to spend hours and sometimes even days to do these tedious setup of installation of operating system, installation of the robotics software framework, make configurations on them, and make sure they work together. And for a company with dozens of employees, hundreds of developers, or even thousands of developers, these wasted time and effort, they add up really quickly. And as a result, what you lose is time for innovation. RoboMaker's dev environment has all these work done for you. You just go to the RoboMaker console, pick the right EC2 instance size for your environment, mount the right amount of storage, EBS storage volume to the environment, click a button, and minutes later, it's up and running. You can start writing your application code. Operating system is there, ROS is there, build tool is there, the integration with other RoboMaker capabilities are already there, so that you don't waste any time, and you can start writing your application code right away. So this is how the dev environment in RoboMaker looks like. It's built on top of the AWS Cloud9 service, a fully featured IDE in the cloud. So you get all the functionalities you get from AWS Cloud9 by using RoboMaker's dev environment. Once you're done with your application development, you can use a compile and bundling tool, come with that environment, and then upload your application to an S3 bucket to run simulations in RoboMaker, which we will get into a bit more details later on. Cloud extensions for ROS. Now, for almost every single robotics developer or companies we've spoken to, all of them wants to add more interesting and powerful functionalities into their robots, but they couldn't quite do so previously for two main reasons. Number one, they were constrained by the local compute and storage resources on the robots. You kind of have to do that, keep limited compute and storage resource on the robot itself to have a reasonable cost structure. Number two is because of expertise. As Roger said, robotics is an extremely hard problem to solve. And if you want to add intelligent functions on top, you got to have to know robotic systems, mechanical engineering, data streaming, video streaming, different areas of machine learning like speech recognition, voice generation, facial recognition. It's incredibly hard to do that. And it's almost impossible for a single developer or a single company to possess all of these skill sets and expertise. That's why we made cloud extensions for ROS. We've using multiple AWS services and written ROS packages or ROS node for these different service integrations so that any developers who is familiar with ROS can easily integrate the power and intelligence of AWS services into your robots. Today, we provide 5 extensions. We have Amazon Lex and Poly for you to build voice interaction features into your robots. You can do things like voice command control. We have Amazon Kinesis video streams for you to do live video streaming into the cloud. And if you pair that with Amazon recognition, then you can do interesting things like facial recognition, object detection, and navigation. We also have logging and monitoring capability through Amazon CloudWatch so that you can get telemetry data and log data off the robot fleet and get insights into your robot fleet. This is how it looks like. The top half of the diagram is what's on the robot. The bottom half is what's in the cloud. This is an example for the CloudWatch extension. As a ROS developer, you can just grab the CloudWatch extension node we provide, integrate that into a robotics application, subscribe that node into a topic with all the telemetry data or login data you want to stream to the cloud. That node will automatically pick up data off that message bus or the topic, and then build secure connection to Amazon CloudWatch and continuously stream the data into CloudWatch. It'll handle failure scenario and spotty connections. What's really cool is to illustrate the power of these cloud extensions. We built 4, actually we just added 2 this morning. Now you can have 6 sample robotics applications in RoboMaker for you to start experimenting with the service. For example, the navigation and person recognition application is really fun to play with. It's an application that can autonomously navigate around a room. It'll do live video streaming using Kinesis Video Stream. And behind the scene, it's using Amazon recognition to recognize the face from the live video stream. And once recognized, it'll pass back the metadata of the person's information back to the robot so that you can do interesting things like call out the name of the person through Poly or move towards that person. All of these sample applications comes with a sample simulation job. So for those of you can actually go to AWS RoboMaker console right now or after this session, click a single button to launch these sample applications and see how they work in a virtual simulated environment. All of these sample applications is also compatible with an open robotic kit called TurtleBot 3. You can buy online, and you can put them together, play with these sample applications, build your own applications, and then use RoboMaker's over-the-air deployment capability to deploy the application into a physical robot and see how they work in the real world. Next, simulation. As Roger mentioned, simulation is a big, big deal in robotics, and it's widely used in robotics development. We've heard from our customers 3 main simulation use cases. Number one is as developers writing their robotics applications, they use simulation as a testing mechanism because it's extremely costly and time-consuming to do the testing on a physical piece of hardware. With simulation, every single developer, they can just test the application in a simulated environment. Once they do quick application update, they can just compile and update that simulated environment and see how that change affect the behavior of the robots. So you get a lot more fast iteration during development. Second use case is for regression testing. So for each of the software application released onto the physical robots, you can use large-scale and parallel simulations, set up different testing use cases to make sure that the new application still pass certain performance threshold and metrics. We have one of our customers who had early access to our beta program. They do software application release every 3 months, which is pretty agile. And out of these 3 months, they had to spend 1 month just to test the application. Pure testing spent a month in the physical world. They were really excited about RoboMaker's simulation capability. Because if you imagine, if by doing that in a simulated world, you can reduce the testing time from a month to a day or 2, what you get is 33% more time for innovation and adding more functionality into the core robots. So that's the second use case. The third use case is for training, machine learning model training. I don't know if you guys saw the announcement with the Deep Racer during Andy's keynote yesterday. So how do you train a robotic car to drive autonomously? Well, you can do that in the real world, and you can try run the car in the real world. It might crash, drive out of the track, you put it back, and you try that for a few hundred days, then you might know how to drive. Well, that's bad. What you can do is using simulation. So the Deep Racer car for the virtual competition, the training is actually powered by the RoboMaker Simulation. What you can do is you can launch hundreds or even thousands of simulated racing track and have the car drive in a simulated environment in RoboMaker. And you can point all these simulators towards the same SageMaker node to train the model. You get 1,000 speed, and you can train in different tracks at the same time. And what's even better is you can run faster in time in simulation than the real world. For example, you can run at 2x, 5x speed, so that in the real world, it's just an hour, but you've trained the model for 5 hours, and you can do hundreds of these at the same time. So that's a pretty exciting use case, and you can only solve that by simulation today. So while developers love the power of simulation, they do not like the fact that they gotta have to provision infrastructure, manage the software, and scale them. At hundreds of thousands of parallel simulations, these work is not trivial. That's why we built RoboMaker Simulation, to run simulation as a service. This is how the service looks like. Throughout the entire diagram, there's absolutely 0 server, infrastructure, or EC2 instances for you to manage. On the top right-hand side corner, you just upload your robot application, upload your simulation application to an S3 bucket, and afterwards you go to RoboMaker, create a simulation job, and just run it. Depending on the complexity of your job, we will scale the backend infrastructure and resource for you. It's 100% pay as you go. After you're done with the job, we stop charging you. On the left-hand side corner, we provide a variety of tools for you to interact with the simulation, and that's really for the iterative development use case I just mentioned. You can see how the simulation works. You can visualize the sensor data of the robot so that you get a view of how the robot perceives the simulated world. You can use visualization tools to see the message passing of your application across all the ROS nodes and topics. You can also use command line tool to interact with the simulation while it is running. On the right bottom side of the diagram, we also provide monitoring and logging capability. And these are really for the regression testing and training use cases. Because when you have thousands or hundreds of simulation jobs up and running, for hours or tens of hours, you probably do not want to stare at them while they're running. So you can actually configure metric and logging functionalities so that you can just say, run 500 of these training workloads for 20 hours. 20 hours later, you come back, look at the metrics, see if everything worked as intended. If not, you can go to an S3 bucket or CloudWatch logs to look at the logs, debug, fix, then run them again. This diagram really illustrates the power of the combination between simulation and the cloud. With the large amount of infrastructure resource and the scalability provided by AWS and the power of simulation, you can run hundreds, thousands of simulations in parallel. So as a developer, you can do things you couldn't do before, and you can get these training jobs done much, much faster than you could do before. Finally, I want to touch on the fleet management capability. So now you've used RoboMaker's cloud extension and dev environment, built very interesting applications. You've tested it in RoboMaker Simulation. Now you have to get the application into your fleet, and you might expand your fleet of robots to hundreds of thousands of them. Traditionally, developers, they either have to build an over-the-air deployment system or fleet management system themselves, or they have to integrate with something out there. Again, we think these are undifferentiated heavy lifting, and developers, they'd rather spend that time on innovation and build their core robotics functionalities. So we thought about that, so we added this fleet management capability into RoboMaker. It provides robot registry, security, and fault tolerance out of the box. You can register your robot with a fleet management service, put a certificate into the robot, then it'll communicate with AWS RoboMaker. Afterwards, you can organize your robot in a concept of fleet. So you can have, for example, a beta fleet and a production fleet. So before you deploy your updates into your fleet, you can try that on a beta fleet to confirm that it works well. And if it works, you can push to a production fleet. Now, this is how it looks like. What's really nice is one of our customers, who will talk about their use case in a bit, really excited about it, is we realize actually a lot of robotics companies, or our customers, they're also AWS IoT customers. So we actually built RoboMaker's fleet management capability on top of AWS IoT and AWS Greengrass functionalities. So in addition to the over-the-air deployment of ROS applications, you get all the capabilities you get from AWS Greengrass for things like local Lambda function, local messaging, over-the-air deployment of machine learning models. So you get a combination of both. You can do very interesting things with the over-the-air deployment capability. Given that, next I would like to welcome to the stage Hamid Monteresi, VP of Software Engineering and Robotics from Stanley and Black & Decker, to tell you about their story. Thank you. Hamid?
Thank you, Ray. Hello, everyone. I hope you've had a great conference so far. It's been a fantastic one, and thank you, AWS, for setting it up. I always find it interesting to give a talk before or after JPL gives a presentation. And as a graduate of Caltech, I've had that opportunity several times. But today, I wanted to congratulate JPL and their representatives for the spectacular landing of the InSight probe. And I can't wait until the day they update the Opportunity website and indicate that this contact is reestablished with Opportunity after several months of the nasty dust storm that Mars went through. Back on Earth, however, my name is Hamid Monteresi, and I'm responsible for the robotics and software engineering teams within the digital accelerator part of Stanley Black & Decker. We were created about 3.5 years ago in order to vanguard the path for more digital and emerging technologies for the company. And today I want to talk to you a little bit about the cloud robotics applications as it applies to construction world. And the things that I'm talking about are not specific to the construction world, but it's something that construction folk can benefit from. There is not enough time today to go over the other applications. So with that said, let me tell you a little bit about Stanley Black & Decker. Most of you probably know us from the tools that we create, and indeed the global tools and storage system is a very big business unit within Stanley Black & Decker that is home to such well-known brand as Black & Decker on the consumer side of the spectrum, all the way to the hardened tools like like DeWalt that is used in all the construction environments. And in between, we have a lot of brands such as Mac Tools, Porter Cable, Bostitch, and I'm fortunate to tell you that about 1.5 years ago, we purchased Craftsman and created a secure home for that iconic brand. But despite the fact that Global Tools and Storage is the biggest business unit within our organization, we also have other business units that are very substantial. For example, we are number 2 in the world with regards to commercial electronic security, which is, of course, a great area for robotics. Within that environment, we have Stanley as one of our brands. If you go to a lot of the major big box retailers, such as Walmart, you see Stanley name on the access doors. The access technology over there is supported and provided by us. And other brands such as Sonitrol and my favorite brand, Hugs, which protects newborn infants against theft in hospitals, which is important for a lot of us parents. And finally, we have another big business unit, $2 billion plus, that deals with industrials. We are a major player in Stanley in engineering fastening through the Stanley engineering fastening part of the business. And a lot of your iPhones have a lot of our connectors. A lot of cars have our connectors. We also are a major player in oil and gas pipeline. Oil and gas pipeline, both for inspection and installation, is a big area for robotics. And also in infrastructure with equipment that tears into stuff and helps demolition. So with that said, I want to kind of motivate our talk today as to why construction is an important area for robotics. So what you see, the graph you see on the right is research that came out of McKinsey in 2017 that shows construction lags behind almost all the industries in terms of digitization and productivity. And construction being a major size in any economy, about 4% of the GDP in the US is, of course, a very significant area for robotics to play a role. To make matters worse, McKinsey's research indicates that there is a significant shortage of manpower in that particular area. About 200,000 people was their estimate in 2017. And of course, robotics can help with mitigating some of that shortage and also bringing more productivity to the world of construction. Having said that, the world of construction is not an easy area to operate in. First and foremost, it's got safety issues, as you can imagine. It also has a variable topology and configuration. Walls go up and things change in that environment. So if you have a robot that does things in that area and is mobile, you can see how it has to be able to cope with that situation. But it also is a great opportunity for many technologies. Already there are advances in AR, VR that are being applied to that environment. Robots are being used, especially drones, for site survey. And new and novel ways of connectivity are being introduced to the environment for IoT applications. So with that said, let's kind of look at the applications that we see currently available within the world of construction. To us, it all starts with site survey and what we call reality capture. Reality capture is about creating a 3D digital representation of an environment or an object using scanning methodologies and applying those sensors. But other applications in robotics in the world of construction that many people have been looking at, and a lot of research is going on to perfect them, is bricklaying, tiling, drilling holes in the right place, concrete finishing, and also demolition. We feel that site survey and reality capture is the key to applying all these technologies because it allows the robot to have a perception of the environment and be able to control everything else in that environment in order to achieve the goals. So in terms of reality capture, the typical sensors that we see, that we use ourselves and we see the industry use, are basically LiDAR, which is a form of laser-based radar. You can think about it that way, and the techniques in photogrammetry, which kind of brings computational geometry and photography together in order to create a 3D representation based on 2D pictures. And you can see a picture of one of the robots that we used to do that, that has a 3D LiDAR installed on it and also cameras to take the pictures. The essential goal and the secret sauce in this activity is to take those pictures, create the 3D point cloud. This is the result of LiDAR and also photogrammetry shows up in what's called the point cloud, which is a collection of precise coordinates for objects on the surface, for points on the surface of objects. And then be able to compare that to the 3D model of a building that usually is called the Building Information Model, or BIM. You can think of it as the CAD model for a building. That action is an area where a lot of AI research and machine learning is being applied to, but it's something that helps the construction industry a lot, because what we have in the construction industry is about a 12 to 15% cost for rework of the mistakes. And in fact, some of the general contractors privately tell us that it can go up to about 30%. And if you look at a $2 trillion business, you can see that that would be a very large number, of the order of several $100 billion. So to look at an example of what typically could be done, I wanted to show you some of the work that my team has done. In this particular video, what you can see is a structure that a robot can go around. In this case, we actually did take the pictures manually and take a number of pictures. And these pictures, using a photogrammetry pipeline that we have set up within the AWS environment, can look at the features between the pictures and correlate them, and then create what we call the camera pose for the places where the pictures were taken. So this is the first part of typically a photogrammetry pipeline. Once that's complete, what happens is that a 3D, after much computation, and again, cloud is a great environment for that, you can create a 3D representation of the structure. This 3D representation of a structure is actually got multiple uses. First of all, it could be an entry point for content into a lot of AR, VR applications. A lot of owners of buildings are now interested in, especially for expensive buildings, to kind of go in and see what sort of changes they might want to make. The other aspect of it is, of course, comparison of this building with the BIM model. And then through applications that we have put together in the AWS cloud, we have the ability to, for example, create the photogrammetry. This is the photogrammetry of an area that was being remodeled in our building, and compare that to a BIM model. And in this particular exercise, based on some specific anchor points, figure out, first of all, match those models together, figure out the exact location of cameras where the pictures were taken, and then based on that, look at how the real picture would compare to a synthetic image that you can generate out of a BIM model that you can see on the left corner of the image. And then you can actually put them on top of each other and see if you can detect any variations, and then you can create a report and send it to the superintendent to find out what they can do about it. So what that activity is very expensive, and access to a lot of construction sites requires a lot of permissions, a lot of safety regulations, and a lot of other concerns. Very time-consuming, very expensive to go and do those things as part of testing your robots. So here is where Amazon RoboMaker comes to our help. We will have the opportunity now, and we have done it within using Gazebo, to bring a 3D model of a building into the environment, and then define a synthetic sensor, in this case, in this particular video, a 400 by 600 camera, and then actually go around that particular model and create synthetic images, capture synthetic images, and push it through the pipeline, and then generate a 3D representation of the environment. This kind of helps us, first of all, simulate how the robot would operate. Maybe the robot is top-heavy and in that environment would topple. It also helps us figure out the best places to take pictures in order to have a great photogrammetry environment. So all these things that used to be done on expensive hardware or individual hardware later on, we could do now in the cloud, and actually provide an environment where these could be shared and built upon. So with that, I'll bring my presentation to an end, and thank you for your attention.
Thank you, Hamid. It's great to see that not only robotics companies, but also companies across different industry segments can use robotics and AWS RoboMaker to improve their customer experience and business. Super exciting. Next, I would like to welcome to the stage Tom Sostrom, Chief Technology and Innovation Officer, and Mick Cox, Lead for Internet of Things, and Eric Jenkins, Lead Developer Open Source Rover, to the stage to share with you guys what they've used AWS RoboMaker to innovate their Rover robot.
Thanks, Ray. Thank you, my friends. So this always gives me the willies. We're going to do a live demo, and you know what happens to live demos. Not only that, it's never been done before. Not only that, it was done with open source, with a huge team of 2. And, but as you'll see, this is minor compared to Insight landing on Monday. We were so happy. And all the JPLers, so hopefully there's some JPLers in the room, if you could stand up, and NASA folks also, stand up and proudly, and then take a bow. I like to think about that. We're one step away from disaster. Failure is falling off the cliff. Success, we take one step back to next time. So we're going to show some things about open source. And anybody know what Spacecraft this is? Boy, you are a shy crowd. Try it again, loud. Huh? Curiosity, good. And notice I called it a spacecraft. To us, a spacecraft and a robot and a rover, it's all the same thing. It's all automated. It's all robotics. So what we do at JPL is we're about 6,200 people now, and we're really an 80-year-old startup. It's an innovation culture, and it's taking advantage of some new trends that are coming that I'll talk about. And okay.
Other way. Other button.
We can land on Mars. We can't operate one of these things. So why do we do this? It's actually not about building the robots. It's about answering these big questions that it's important for humanity. Are we alone? And how do we, is there life out there? Where did the universe come from? Where is it going? If we one day needed to evacuate humanity, would we have a place to go? Can we find Earth 2.0? So it's about that. But it's about involving everybody to do that. So we have roughly 30 spacecraft and instruments across the solar system and beyond, actually outside the solar system. Voyager is now 15 billion miles away. So those are complicated spacecraft. They're very difficult robots, but we have to learn how we get there. The problem so far has been a very specialized field of scientists and engineers and roboticists and programmers. So can we create a platform where we can take advantage of the innovation that all of you have? I keep doing this. So if you look at this, we've created an interstellar network, an IoT, essentially, of space. We've even extended internet into space. So there's a lot of things that we can do going forward. And we're going to, if you look at the ones on the top right, it's Insight that just landed. It was also 2 CubeSats. A CubeSat is about a satellite that's about this big, and they flew all the way to Mars, and they recorded and transmitted the pictures. That was unthinkable 2 years ago. It was just a toy. That would never work. It couldn't possibly go 300 million miles, but it worked. So when you see this next demo, think about the toy, but think about the toy that is moving forward. We're catching the next technology waves. And the technology waves are the waves of huge interest in space, very big interest in robotics, open source, and the innovation from all of you. And the big enabler of all of it is cloud computing. So we were involved in RoboMaker pretty early on, and it's very interesting and exciting for us that AWS is moving into robotics, because that can help us answer those big questions. So, did I do it again? No? So, how can we use this? So today's toy that you'll see is tomorrow's tool, and you're going to be the tool makers. So as you see this one, One of them is going to be a robot. The other one is going to be a human. You have to figure out which one is which. But also imagine that the human is not, that the robot is not here, but it's actually on the moon. So we use robotics to explore dangerous places, to prepare for humans. And this robot could be on the moon, and as Mick shows the demo, just imagine that it's you showing the demo next time. And it's the robot that you built or that you added features to. So that's the whole key to the open source robotics. So we built it open source. It was released at the end of July. It's been very popular. And this is really for high school and up. It's about learning, programming, robotics, engineering, and science, and working together hands-on. So now let's see if this, to me, very scary demo will work. So Mick and Eric, take it away. And also, open source Rover, take it away.
All right. We'll see if I get lucky with the slides here. So what you're seeing on stage and what you're seeing on the screen is now our open source rover. So JPL's built a lot of cool stuff and sent a lot of cool stuff to Mars and elsewhere in our solar system. Every time we take a model or a demo or something to a school, a museum, somebody asks us, do you have plans so that I can build one of these things? So what Eric Junkins here sitting in the front and Liv Lafaro did for us over the summer is basically design exactly that. We went to online retailers, Amazon, DigiKey, McMaster-Carr, other places like that, and we built a small scaled-down version of the rover that does much of the similar stuff that the rovers all do on Mars. This is our website that you're looking at. It has a lot of information about this rover. So if you have a high school, if you feel really inspired yourself to try and build a rover, you can get on that website, see whether or not this is the project for you. From there, we also link to our GitHub where we have all of the plans, all of the parts list, all the instructions for putting this together, so you can get that, contribute that back if you want, improve it, move the whole project forwards. And then we also have a forum where you can chat with other people that are building this rover at home as well. So with that, I'll show you just a quick on the left there is our GitHub repository. On the right is that forum. So now we'll get into the really fun stuff. And by fun, I mean terrifying. So the very first thing that we wanted to do with this robot, when we heard about RoboMaker, was can we simulate this thing in RoboMaker, right? It's a simple enough question. We already had the CAD. We had the 3D models generated already. With a little bit of effort, we wound up putting them in a simulated environment. So physics are real. Everything is happening in the simulation. Visualization of your robots is extremely important. You might have tens or hundreds or even thousands of data points coming off of this thing at any given time. Some of them might be images, pictures, point clouds. You can't really visualize that on a command line coming through. So what we wanted to do is build a 3D environment where you can actually visualize this rover. Now, in addition to the simulation, where this thing is sitting, we've installed some sensors on the rover. So the things that we've installed are accelerometers on all of the legs, so we know where the legs are. And then we've installed a temperature and humidity probe, and we've installed a camera. So what I'm hopefully going to show you now, this thing is basically streaming all of the data out to the cloud. So if I take one of the legs and lift one of the legs up, you'll see that there on the screen. So this is responding. Thank you. So this one is streaming all the data to the cloud. Ray was mentioning the cloud integrations that are built in. We've put a couple of those on the robot as well. So speaking of temperature and humidity, we're streaming all of those metrics straight to CloudWatch. So as the rover is mentioning, it's really getting hot up here. And then there's the humidity down at the bottom as well. So that's streaming. There's also a Kinesis video plugin built straight in. So we've installed that with our little Raspberry Pi camera. And if I actually go to the newest stuff, fingers crossed that the Wi-Fi is holding up. There's the live video feed of the room there. So this is all fun and good, but now we want to do something really, really fun with this rover. I'm from JPL, so I just carry around with me robotic arms. And what I want to do is install this robotic arm on the rover. So the rover is a basic package, a platform. We want people to build new things and contribute those back. So as an example of one of those things, we want to attach this robotic arm to the rover. Now, I'm an OK developer, but I don't trust the first code that I write is going to be perfect. So I need to simulate this first before I can actually attach this arm. So what we did is we built a simulation with the arm on it. And in that simulation, we also dropped a human robot. So I wrote some code that will watch the human robot and basically mimic exactly what the human is doing with the robot arm. So the application here, as Tom mentioned, if this thing is on the moon, maybe I want to do a teleop kind of robotic arm demonstration with this arm. So what we'll do here is I'll start publishing messages to the human arm. The human arm will move back and forth, and then hopefully the robot arm will see it and respond. Okay, so we know that all our code is working in the cloud environment. It's working in SIM. You can use that fleet management and deploy it directly to the rover. And we'll do basically a demo of that here. So now we've got the modeled rover sitting there. I'm going to come down here, snap this arm on. Bet you've never seen this on stage at reInvent before. Plug this in. All right, so now our robot arm is there. This laptop is basically a computer. That's the dumbest thing I've said all day. It's basically a camera. Thank you. It's a camera that's running, and I've got a small depth camera up here that's going to watch my movements and try and figure out where my skeleton is. And we're going to send that to the robot. It's booting. It's booting. Still firing up. OK. Here we go. Look at that. So you can imagine, this would have been a much longer, slower process if we didn't have a simulation environment to run all of this stuff first. So I'll walk out of here, and hopefully it's going to be calm. Put that down just in case. So with that, JPL is pretty excited about what RoboMaker might be able to do. We're always looking for the next new technologies to build our robots faster, better, smarter, cheaper. And we're really excited to see where we might be able to go with RoboMaker and other technologies like this in the future. With that, I'll hand it back over to Roger and Ray. Thanks.
Well, thank you, Tom, Eric, and Mick. What an awesome demonstration of the capability of the Mars rover and how RoboMaker can help robotics developers innovate faster. So just to recap, what is RoboMaker? RoboMaker is a new AWS service that helps developers to develop, test, simulate, deploy, and manage intelligent robotics applications. We have cloud extensions for ROS, provide you with ROS packages that make it easy for you to integrate AWS service capabilities into your robots. We have a dev environment in the cloud with all the software, infrastructure, and toolings you need set up out of the box so that you can start writing an application from day one, from the very beginning. We have a simulation as a service that allows you to run large-scale and parallel simulations with no infrastructure provisioning or management. And we also have fleet management capability for you to do over-the-air application updates and deployments while the robot fleet is in use. Now, with that, I want to thank you all for coming to this session today, and I hope you enjoy the rest of the conference. Thank you for coming, guys.
Education, okay? Thank you. Just one last closing comment. As part of Amazon's support for robotics and support for open source, all of the cloud extensions that you've seen in action here are being released out to the open source. We're also working with the Open Robotics Foundation to extend ROS2 and donating open source software to that as well. Also pleased to announce that we have a partnership with First Robotics. First Robotics is not just about youth making robots, but robots making the next generation of science and technology leaders. And we're going to have some very fun contests coming out with First Robotics and RoboMaker next year. And I'm also pleased we have partners, Advanced Robot Solutions, Persistent Systems. And I'm also pleased to announce that we have a very strong education and research engagement program with leading universities around the country, around the world, actually. In fact, we just added MIT and USC today, where they'll be provided with RoboMaker for teaching and also using it for research as well in robotics. So a very exciting space. Again, I'd like to thank our customers and partners for coming with us today, and thank all of you for joining us here this afternoon. Have a great day.